Hello again. We are moving on to our next unit. We're going to be talking about quantiles or k-values. This is lesson 7.3, so let's get started. In the last lesson, we saw that we were given a data value and asked to find the percentage of data that was less than that data value or between two values. Well, now we're going to be asked to do the opposite. So now we're given a percentage of data and we're asked, well, below which data value can we find this percentage? Okay, so let's go through a couple of examples. Let's say x, and let's go through that notation. X is distributed normally with a mean of 10 and a variance of 4 squared. That means that the standard deviation is 4. Typically they list the variance as being something squared. If they don't, you need to be ready for that, and that second parameter will be variance. So you'll have to take the square root of it. So I know my standard deviation is 4. So now I need to figure out, instead of finding the probability that x is less than a certain number, I have the percentage. I have that it's 80%. Well, I need to know 80% of the data is below which number. So just like there was a function for finding those probabilities, there's a function for finding those numbers as well. And since we're doing the inverse of what we did before, if we have a probability and we have a mean and we have a standard deviation, we use the function inverse norm, or inv norm CD. And here's the order of the parameters for a Casio. You do the probability first, then you do sigma, and then you do mu. Sigma and mu are last again, just like they were when we were doing normal CD. And again, just like with normal, once you switch to a TI, you've got to switch the order of those last two numbers again. And mu will come before sigma. So just remember that those last two numbers need to be switched. All right? So in our case, we have a probability of 0.8. We know that mu is 10 and sigma is 4. So our answer is 13.36. I enter in those three numbers. Depending on which calculator I use, that's what I get. All right, here's another example, because you may not always be asked to find a less than situation. So now I have another x distributed normally. The mean is 62. Looking at the variance, that's 12 squared, so the standard deviation is just going to be 12. I need to find the value so that the probability of being bigger than that value is 80%. So now this isn't a less than situation anymore, but less than is all that my calculator can handle. Well, it's just a simple matter of subtracting from 1. If 80% of the data is bigger than k, that means that 20% of the data must be less than k. So it's fixed. I know that all the probabilities have to add up to 1, so the probabilities that are less than a certain value and the probabilities of those things that are bigger than that value are going to add up to 1. So if I don't have the one that I want, I just subtract from 1 and I get the probability that I need. So now my p is 0.20, my mu is 62, my sigma is 12, and in a Casio, I do inverse norm CD, 0.20. 12 is my sigma, 62 is my mu. Using a TI, the probability still comes first of 0.20, but now the mean comes second of 62 and the standard deviation goes last of 12. Either way, I get an answer of 51.9. So that's how I do those types of questions. They're called quantiles or k-values, so get ready to see those words floating around and know what to do when you see them. If you have any questions, please let me know, and I will see you tomorrow.